Hi all, in this video we are going to see the project demonstration in temporal difference learning, which is a reinforcement learning technique where an agent learns from experience step by step instead of waiting until the end. Here the agent will update its knowledge after every move using the reward and the next state value. So the TD learning is based on the idea of learning from the difference between current and next state. The update is done using the TD core logic formula. The value of the current here, which is the current state, is updated using the reward and the value of the next state. This is the core logic of TD learning implemented in this program. And I implemented this using the grid world environment where the agent is placed at the starting position and the goal is set as the target of this environment. And there are some obstacles for the negative states also. The agent interacts with this environment by moving in 4 directions, which I specified in the here. This is the configuration part of this project, where there are the 4 directions like up, down, right or left. And in rewarding systems we are having the plus 10 for reaching the goal. When the agent is reached the goal, it will get the reward as the 10 points. When it hits some obstacles in the environment, it will return as the value minus as the value already set to minus 10, which giving the negative reward. And also there are some several states for moving. For that purpose we are assigning the -1, which will reduce the value of -1 to the existing value. And we are coming to the code structures, and here I already said the configuration part where we are setting the where the start and the goals are placed in the grid, and also the obstacles, and here the actions parts, that 4 directions also, and alpha and gamma, which will be used in the formula for learning that environment. And here this get reward and get next states controls how the agents interacts with the environment. From these functions it will learn the environment much more. And here we are updating the states, as I already told. It is playing as the core logic of this program. And we are coming to the training part. The training part here, this function will write multiple episodes where the agent moves and learns continuously here. And in the decision function, which is the get best moves, according to its learning it will choose the next state as the best option. And for visualizations I added the arrows, agent, goal and obstacles indicating the best directions for the and now we are going to run this. As I built this program in Streamlit, we want to run this program using the command Streamlit run and the file name app.py. Now the agent is placed in the starting position and the goal is placed in the ending positions, which is indicated as the green. And there are some obstacles which are indicated as the red circles, and other states are indicated in the arrow symbols. And after the training, this arrow directions will be represented according to the optimal learning. And we are going to train this, and we can able to see the table value. This table value indicates the values which are nearer to the goal state will have the small value, which will indicate the goal is nearer to this states, and the states which are far from the goal state will have the highest value, which will be the negative highest value. And this is the learning progress. We can able to autoplay these agents This autoplay agents will play according to the arrow directions, which will take the optimal path based on the learned values. Thus the agent successfully learns the optimal path using the temporal difference learning by updating the values step by step without waiting for the final outcome. Without waiting for the final outcome, this learning will be done before it. This project implements the JD learning in a grid world where the agent learns optimal actions by updating start values using the reward and next value also. Over time, it learns the best path to reach the goal. Thank you. That's all.